So we're now going to connect your BBC microbit to Bitty Data Logger. We'll show you how to do that and then how to send the information. For ease of demonstration, we're not going to have the microbit attached to the plane, so it's better if you attach it, couple it and set it up before you put it onto the plane. It will store it in your Bitty Data Logger if you do that. So set it up beforehand and then attach it to the plane. Excuse me. So once you've got one set up to your device, it will recognize that, so you can take it off and on any other planes, so you can take the readings from each of your pupil groups when you're doing the resource task. So we use this app called Bitty Data Logger. You can get it from the Play Store. We're doing it on Android, but it also supports on iOS as well. So it costs £1.99. Sadly, when we started the project, it was free, and then the chap who did it, I think, unfortunately decided to put a £1.99 price on it, and we can't get around that, sadly. So you would go to Play, pay £1.99, and it downloads onto your mobile phone. We found that mobile phones are actually probably the best place to do it because it's in hand, it's small, it's relatively easy to use. So whether that's your phone or if you're comfortable using the pupils' phones, then that's absolutely fine. But remember, it is a £1.99 cost. So if you've got 5 or 6 pupils that are doing it, that's going to be 5, 6 times £1.99. So once you've got it logged onto your phone, you open the app and it brings up this particular set of options. You need to couple your microbit to your battery and then hit scan. So it finds it's the microbit there. If we tap on that, we then have other options. We want to hit settings, and we can see you can add a project name or your team. You're going to collect only accelerometer data, so tick that box, and you're going to collect it in, you can collect it in the X, Y or Z. To select all of them, we're going to be using the Z. We're going to correct the sampling at 20 milliseconds, so that's how quick that the data is sampled, and we're going to export it as a CSV file. And we just go back, and going back takes you to the screen. So when you're ready to collect the data, you simply hit start. And what we can see is we have a blue, red and a yellow line. As I move it, you can see that it collects and picks up the data. The accelerometer is very, very sensitive. So if you move it up and down in the Z direction, which is in yellow, you can see that the greatest effect is in the Z direction, up and down. And that's going to be the direction which you're going to collect your data for the how high can you fly challenge. If I stop, it all levels out. So we've got G's on this axis here, and we've got time on this axis here. So x-axis time, y-axis on the graph is milli-Gs. So if I move it forward and back, you can see the differences in the force that the accelerometer is measuring. So we can go forward and back, we can go left and right, and we can go up and down. So this proves a way to be able to see and to quantify how the aeroplane moves. And if you see I move in the roll, or in the pitch, or in the yaw, you can see how the data is generated. You can see because it's 20 milliseconds, it's collecting it quite a lot, so there's an awful lot of data being collected. If you do to select 80 milliseconds, which is another option you can collect it, you will collect even less data, so it would look less noisy. So either 20 or 80 milliseconds is your choice. I've got it set to 20 milliseconds collection here. So at this moment it is collecting the data. So this is a good way to be able to show the force of gravity and the different forces through the accelerometer when moving the aeroplane. So it's interesting to note that when it's still in level, that is how the G's are collected, but if we move it at an angle, you will see that it changes the amount of gravity that it records. That's because there's an angle, an angular component moving through the axis. So the gravitational force is not completely vertical. It moves and changes like that. For our experiment, the slight changes in this pitch in that direction should be relatively negligible, but it does mean there's an error in some of the data, and we just accept that. It's been quite complicated to iron that out. But nevertheless, we just simply collect the data in this form. We just stop it there. And we can just miss that OK, because that was for the Bloodhound project, which we're not going to use, because this was originally designed for the Race to the Line with the Bloodhound team. So if we now, let's want to, for example, start a measurement with our plane, we would make sure that the plane is ready to be launched. When you're ready to hit the start button, you will say to the person or the people that have the plane, go. You will start that, at which point the people then let go of the aeroplane until the aeroplane takes off, lands and stops. And when it's stopped, you hit stop. OK that. Then you go to results, and the top line of data is the newest amount of data. So you hit that, and then you hit share, and then you go to Outlook, and then you simply put in your email address, and hit send. That's the data sent. In any second now, we will hear that arrive in our inbox. He says waiting. What's important to know is that once you've collected the data, you actually can't see it again on the phone. You can only see that data when it's collected in real time. Once you've gone to share it or send it, you can't go back to see it. You then have to process it to be able to see that data. So that has been sent, and it will appear in the inbox. And when you have it on your inbox, that's when you go to your computer, and we can use Excel to then process the data. And there it is, it's just arrived there. And that's the data. Arrived as a CSV file. And there's our data. In X, Y, and Z, that's our data there. So we just then open it and we paste it into our template Excel document, which we will show you next.